Hello, scholars. Welcome back to our live classes. This trip is going to be focusing on graphs. I'm going to introduce you to plotting and interpreting graphs, both linear and quadratic graphs, which at the CSEC level, these are the two graphs that are featured. I'm going to take you from the very basics, the fundamental concepts. Once you grasp those, you will be able to plot and interpret any graph, any linear or quadratic graph at this level. So allow me now to just quickly grab the link and share so others benefit and on board. I don't yet see the link for this. All right, hopefully they'll go over to YouTube. And for those who are not yet familiar, let me tell you of the schedule of classes that we're going to be having. I will be repeating this near the end of the class. But let me tell you now, the schedule for classes for the CSEC from Monday to Thursday is going to be 8 p.m. to 9 p.m. And on Monday, which is today, we're going to be doing graph. On Tuesday, we're going to be doing algebra. Wednesday, we're going topic by topic. So we'll choose a topic and explore that topic. And when that is finished, we'll go on to another topic, different from the graph and the algebra. On Thursday, we're going to explore the different formulae used at the CSEC level and shortcuts that you can use to avoid, unnecessary working out, particularly in the multiple choice paper. You do know, well, you should know that the CSEC paper, on the second page, there is a list of formulae, and some persons just skip right over that page and they don't realize that it's a great resource for them to use to answer some of the paper 2 questions, right? So we're going to go through those formulae and familiarize you with them and let you know what you have right at your fingertips. On Thursday, that's the midnight class from midnight to 2 a.m. That would be the CSEC Math Paper 1, the multiple choice class. And so 2 classes on Thursday. So all you have to do is when the class ends at 9, when the formula class ends at 9, you just grab a quick dose and set your alarm to wake up back maybe 10 minutes or so before midnight so you can freshen up, drink some water, and come right back. And then on Friday is from 6 to 8 p.m. where we're going to do the CSEC paper 2 questions. The paper 2 questions have different parts, usually getting gradually more difficult. And usually the earlier sections, the answers that you get in the earlier parts of the question you need them to solve the later part of the question. All right. All right, I'm going to run back over and try to get the link. Let me chat. Hi, Jaden. Guys, when you come on, just type good evening, teacher and your fellow scholars. For some reason, this isn't showing up, but anyhow, I'm going to leave it alone. Sometimes when you leave things alone and come back, it sorts itself out. All right, so we're going to be using the board because, graph is it's a very technical thing. It's a very hands-on thing. It has some artistry involved. And so with practice, you get better and better. I love to see when the graphs are sharp and clean cut, so I advise students to have their pencils sharp. And in terms of the graph paper, I would advise you to choose the paler paper. Can you see the board clearly, guys? All right, I think you should be able to see that. No. Okay. Good evening, everyone coming on. Welcome. Welcome, welcome. So we're looking at the basics of graph. So we're going to start with the coordinate plane, also called the Cartesian plane. Now, I do not draw straight lines, so we're going to imagine those lines are straight, okay? Imagination, pretend that they are straight. So this is the coordinate plane. Coordinate plane. Also called the Cartesian plane. Named after René Descartes, who was a French mathematician. So on the coordinate plane, we have two axes. We have our x-axis and our y-axis. So we're going to put little arrows, particularly on the positive section of the axis. And these arrows indicate that the axes continue indefinitely to infinity. So that's what the arrows mean. And we're going to put x and we're going to put y, right? Our coordinate plane begins at 0, 0, 0, 0, 0. That's 0 in the dead center, bullseye. So this is called the origin, and the coordinates for here is 0, 0. So we write coordinates in pairs, in brackets like that. So for example, for the origin is 0, 0. The origin. But we could have any numbers here, and they could be negative as well as positive. We could have both negative, both positive, one negative and one positive. Now let me explain what it means when the pairs are negative or positive. So let's look at some examples. So I'm going to use capital letters to represent. Let's do 5 of them. So we write our coordinate pairs in brackets. And the first number tells you where to move on the x-axis, and the second number tells you where to move on the y-axis. After you have moved in pairs, then you have made a point. So you don't write the point on the first movement, you write it on the second movement. So let's say we have -3, 5, 3, 5, -3, -5, 5, 3, 0, 4. All right, so let's look at those pairs of coordinates. Oh, you can't see further down. All right, but I'll read them to you so you'll know what they are. Okay, you're not seeing below here. All right, so remember now, the first number tells you where you're going to move on the x-axis. The second number tells you where you're going to move on the y-axis. After you move 2 times, after you make both movements, then you put a point. Now, I'm going to number my axes. Usually, not always, but usually on the x-axis, we can space out our numbers, and I'll explain the scale in a minute. Because the numbers on the x-axis tend to be smaller. Usually your x values tend to be smaller. Your y values sometimes go up into the teens, the tens, the hundreds. And so in order for it to fit on the graph paper, we have to use a different scale for the y-axis. So let me explain. Good evening, Dreshan. Let me explain what we mean by the scale. Now, if you have ever looked at a graph sheet or a grid, you will notice that it has little boxes. How do I turn off camera lights? Somebody is asking me a technical question. They're assuming that I know anything about technology, which I don't. I have to ask my students to help me. I have to ask my students to help me. I'm afraid I can't tell you how to turn on camera lights. What? Oh, turn off. Alexander. Oh, it's Alexander. Hi, Alexander. Long time no see. If anybody knows the answer to that question, can you type it in the chat for Alexander? He wants to know how to turn off camera lights. I am of no help to anyone when it comes to technology. All right, so help him out for me, guys. I know one of you probably know what he's talking about. All right, so the scale is the space, the value that you're going to give to the space on each axis. Now you can have a different scale for the x-axis and a different scale for the y-axis. But whatever scale you choose for each axis, it has to be consistent along the axis. So if you choose to go up by 1 on the x-axis, both positive and negative. If you're saying 1 box for 1 unit, it has to be consistent. 1 box to 1 unit. If you're saying 2 boxes to 1 unit, it has to be consistent. But you can choose a different scale for the y-axis. On my y-axis, well, for this activity, I actually can go up by 1 because my biggest y digit is 5. But usually when we're doing graph, the y-axis, we can go up by 2, we can go up by 5, even 10. Sometimes you need to go up by 10. So this is the positive y-axis, and down here now is the negative. Now bear in mind, we number from the center out. So from 0, 0, which is the origin. So from 0, 0, out, 1, 2, 3, 4 on the positive x, negative 1, negative 2, negative 3, negative 4 on the negative x. Likewise, on the y-axis, from 0 out. From 0 up, 1, 2, 3, 4, 5. From 0 down, negative 1, negative 2, negative 3, negative 5. And this is our coordinate plane or our Cartesian plane. So now we're going to plot these points. And we're going to put letters just for today's sake. Normally, when you're plotting your linear graph or your quadratic graph, you're not going to put letters there. You're just going to put the points, and then you're going to connect the points to create either your line or your parabola, which is the curve for the quadratic. For this exercise, though, just to show you where the points are, to use capital letters to represent the point. So point A, the coordinate, that means we're going to move negative 3 on the x-axis, 5 on the y-axis. So starting at 0, 0, negative 3 on the x, so that's negative 1, negative 2, negative 3. We don't make the point yet. From here, we're going to go up 5 on the y. So from here, 1, 2, 3, 4, 5. So now we make the point, and that is point A. Right? Point B is positive 3, positive 5. So on the x, we positive. So from 0, positive 3, and from here, up to 5. And then we put our point, this is B. So look at the difference. Negative 3 to positive 2, totally different. All right, so for point C, it's negative 3 and negative 5. So it's negative 3 on the x and then down, because when it's negative on the y, we move down. So positive on the x, we move to the right. Negative on the x, we move to the left. Positive on the y, we move up. Negative on the y, we move down. So this is a negative 5. So from negative 3, we're going to move down and put our point there. And that's point C. That's positive 5 and positive 3. So positive 5 on the x, and then 3, positive 3. And point 0 on the x, and 4, positive 4 on the y. Now, what are we going with 0 on the x? What does that mean? What does that mean? Anybody wants to tell me in the X, 4 on the Y? It's 0. That means we're here. Remember what's here. Good evening. I'm in a live math class. All right, so 0 on, we start here. Excuse me. All right, so we start here and we go up to 4. Okay? So 0, 0, we're still here at 0. They're telling us don't move on the X. Don't move on the X, we're still at 0, but then move on the Y. So from dead center here at 0, 0, we go straight up, and that is 0, 4. All right, so that is point E. So what we're going to do now, I'm going to put the points on the coordinate plane, and then from those points, we are going to determine the coordinates for the points. Okay, so we're going to determine the coordinates for the point. So let me put that in. So we have our x-axis, y-axis. Let me quickly put back my scale. All right. So I'm going to put some points. So you should be able to get the coordinate pairs and plot the points, as well as you're given the points, and then you have to determine what are the coordinate pairs for those points. Okay. So I'm going to put a number of points. And we're going to figure out what are the coordinate pairs for those points. All right, so this is point A. Okay, so there we have our points. There we have our points. So let's figure them out together. So point A, here is point A. Remember, we start moving at the origin, and we move on the X first, and then we move on the Y, right? So we move on the X, and then we move on the Y. So look where point A is. Look where point A is, and see if you can figure out how much did we move on the X and how much did we move on the Y. Remember, we start moving from 0, 0. So did we go to the left or the right on the X? And did we go up or down on the Y? If we're moving from here to get here, we had to move to the left 2 places and then down 1 place. So that would be -2 on the X and -1 on the Y. So that's -2, -1 for point A. Look at point B and see if you can figure out and write down what are the coordinates for point B. Do we move to the right or left for the X? And do we move up or down on the Y? That will determine whether it's positive or negative. All right, so quickly jot down the points for B. And now let's do it together. So to get to B, leaving here at the origin, we have to move 1 place to the right, so that's +1 on the X, and then 1 place up, so that's +1 on the Y. So that's the coordinate pairs will be 1, 1. 1 on the X, positive, and then up on the Y, that's also positive. So 1, 1. For point C, starting at the origin to get to C, we had to move to the left. So that's -3 on the X, and then we moved up 4 on the Y. -3 on the X, 4 on the Y. I hope you're getting all of these answers. I don't see you type answers, so I can check if you're getting them. So I'm assuming, does everybody agree so far that we have, for A, it's -2, -1. For B is 1, 1. And for C, -3, +4. All right, for D, so D is over in the 4th quadrant. Points that are in this quadrant will have a +X and a -Y. So this is the first quadrant. First quadrant, both the X and Y are positive. Second quadrant, -X, +Y. Third quadrant, -X, -Y. Fourth quadrant, +X, -Y. So for D, we move positive, then -4. So we move, okay, so I see Imani, John, and Amari got their 1, 1. What do you have for D? So for D, we have +4, -4. How about E? So E is all the way over here in quadrant 1. We know both the X and the Y are going to be positive once it's in the first quadrant. So 5 on the X and 5 on the Y. So +5, +5. All right, so we have to go. Okay, so Drayshawn got +5, +5 for E. For F, so F is here. F is on the y-axis. So that means we did not move on the X for F. We did not move from the origin. We just went straight down to -3 on the y. That means it's 0, -3. Not 0, 3. It's not a positive 3. 0, 3 would have been up here. So this is 0, -3. So that's F, 0, -3. And for G, G is also on the y-axis, so we did not move on the x for G. We stayed put and then we moved up. So that's 0, 5. So look carefully at the points and see if you understand how we got those coordinates. Some persons are saying their image is blurry. I've been trying to iron out some issues that read the quality of the presentation, but just give me a little time. Like I said, guys, I'm not very techy yet. I will become tech wizards like you guys are, but just give me some time to sort that out. So let's recap. Point A, we moved -2 on the x and down -1 on the y. For point B, we moved +1 and up +1. For C, we had to move to the left on the x-axis, so that's -3 and then up +4. For D, it was +4 and then down -4. E, we moved +x, +y. So that's +5, +5. Okay, and F is on the y-axis, so that's 0, -3. And G is also on the y-axis, so that's 0 to 5. So what we're going to look at now is something that I mentioned earlier, and that is the 4 quadrants. All right, so let's just on the coordinate plane, we automatically have created 4 quadrants. Okay, so this is the first quadrant. Second quadrant. The third quadrant. And the fourth quadrant. Now, where a point falls, in which quadrant it falls, that will determine whether it's a plus or a -y, and vice versa. So if it falls anywhere in this quadrant, the x is going to be positive, and the y is also going to be positive. So P for positive, N for negative. So if the point falls anywhere over here, because remember, it means that the people in the group are saying they don't see it. Just ask them to go on YouTube and follow the link. All right, so in this quadrant, anywhere in here, the x is going to be positive and the y is going to be positive. If it falls along the y-axis, the positive y-axis here. You know the x is 0 and the y is positive. So if it falls along this axis, this part of the y-axis is 0 on the x and then a positive value on the y. If it falls within this quadrant, the second quadrant, we know that the x had to be negative and the y is positive. So negative x, positive y. If it falls along this part of the x-axis, then we know that the x was negative and the y was 0. So we'd move a negative number on the x and then we would not move again. We would stay on the x-axis. So that means 0 for the y. Down here in the third quadrant, we have a negative x and a negative y. So in here, negative x, negative y. Once it falls in here. If it falls along this line, if it's a point on this negative y-axis, then it means the x value was 0 and the y value was negative. And you can look at it logically, look at how the quadrants are set up and you will see any point along this line. That means you did not move on the x-axis, you just moved on the negative y. So 0, negative y. In the fourth quadrant, we have a positive x and a negative y. And if it falls along this x-axis here, it means you moved a positive x and then you did not move for the y. So that means positive x value and 0 on the y. So let's recap the quadrants. First quadrant, the x is positive, the y is positive. If it falls on the positive y-axis, x is 0, y is positive. If it falls in the second quadrant, we have a negative x and a positive y. Along the negative x-axis, the x is negative and the y is 0. Third quadrant, negative x, negative y. Negative y-axis, that means the x is 0 and the y is negative. Fourth quadrant, both we have a positive x and a negative y. I didn't write that one in. So positive x, negative y. And if it falls along the x-axis, the positive x-axis, then we know that we moved a positive x value, but we did not move on the y, so the y is 0. And just looking at the coordinates, you can picture in your mind or have an idea where the points are, and you can actually make sketches. Because sometimes, even in the paper one, the multiple choice questions, you can actually just make a sketch and determine which answers can be eliminated and just to narrow it down, you can just sketch your coordinate plane and have a clearer idea of what the possible answers are. Because remember, when you're doing multiple choice, even if you have to guess, try to make an educated guess. Try to make a smart guess. Don't just eeny, meeny, miny, moe, just pick a random answer. Eliminate the ones that cannot possibly be and narrow it down so you can make the best option. You can pick the best one. All right, so this is it for the fundamentals of graphing. Using up the coordinate plane, knowing your axes, knowing whether you're on the positive or the negative for both the x-axis and the y-axis. Remember, for the coordinate pairs, the first number tells you where to move on the x-axis, and the second number tells you where to move on the y-axis. That's very important. Again, we're not going to be using letters, so I just use the letters for the purpose of this course. Now, what I'm going to do for those who joined late, I'm going to read over the schedule of classes that we're going to be having for the CSEC, the live CSEC classes. So you can write down this schedule and so you can benefit from all the classes. We're going to have live CSEC classes every day, every weekday during the week, not on weekends. So the schedule for the live CSEC classes weekly from Monday to Thursday is 8 to 9 p.m. On a Monday, like today, we're going to do graphs. So that's plotting and interpreting graphs, both linear graphs and quadratic graphs, as well as combinations. So for example, learning how to solve simultaneous equations using graph by intersecting graph, and learning how to read the graph to get information. We're also going to be doing graphs like linear programming, which will help us to solve problems of maximum profits and so on. So everything pertaining to graph, we're going to be doing in this class. Graphing inequalities, all of those. On Tuesday now, we're going to focus on algebra. So we're going to do, so that's tomorrow, we'll do the fundamental algebra class from the basics, and then we're going to move steadily straight up to things like simultaneous equations, solving linear equations, factorizing quadratic equations, and so on. On Wednesday, we're going to have a topic by topic session. So what this means is that somebody's asking when will we be doing the linear graphs. We're actually going to start the linear graph next week because we have covered the fundamentals in graph today. So next week, Monday, we can go straight into plotting. Or maybe we'll do plotting inequalities first. Yeah. And then we go into the linear graph. So the topic by topic, we're apart from the graph and the algebra, which they have their days to themselves, the other topics, we're going to go one by one through each of those topics. For Thursday, we're going to look at the formulae and shortcuts. So we're going to break down the different formulae that we use in the different topics. And so you don't have to try to memorize the formulae. Once you understand how they were derived, you can actually derive them from scratch yourself. As well as the fact that the CSEC booklet, the paper 2 booklet, has a number of formulae on page 2, which a lot of students just skip that page. They don't even realize that the very formulae that they need to solve the problems are there. How kind of the examining body to give you the formulae that you need, and you just skip over them. So we're going to go through those formulae, and so you understand how they were derived and when to use which one. Thursday, we have 2 classes. So we have the 8 to 9 class, and we also have a midnight class, which is a paper 1 class. So that's the multiple choice. And we're going to try to do as many multiple choice questions as we can fit into the 2-hour session. And on Friday, from 6 to 8 p.m., we'll do the CSEC paper 2 questions. So that should cover everything that you need to know. So if you tune in every day to the live, by the time your exam comes, you should be well versed. You should be walking into that exam room confident with a smile on your face, because you know that any way, any direction they come at you, you're going to be able to handle it. So you notice I've covered all the bases. We have, if you master algebra and graph, and you master how to approach your multiple choice questions, you're well on your way to passing CSEC math. And we're going to be doing the other topics as well, but I'm just saying those topics are, they are featured heavily in the exam. If you master how to read your graphs, how to plot them, how to interpret them, and you master your algebra and your paper 1, I have found from my experience that a lot of students fail the math exam because of the paper 1. And if you look at the paper 1 questions, you realize that some of it, even some very basic things that you would have covered from even the elementary level, from grade 6, grade 5, grade 6, things like percentage and fractions and ratio and decimals. If you don't have a fundament, the foundation, a strong foundation in those topics, you're going to fail the paper 1. Remember, the paper 1 multiple choice, you're not allowed to use calculators. So you have to be able to work it out on paper. And a lot of students, they focus a lot on the paper 2. When they go to the marathons and you know, classes, they focus on paper 2. They swat the answers. They don't know how to derive the answers. So if the question come at them from a different angle, or if anything at all changes in the layout, they don't know how to handle themselves. They have to have the question as it was. I don't want my students to be like that. I want you to understand what is happening from scratch, and whichever way it comes at you, you're going to be able to handle it. So we're covering all the bases, all of the bases. By the time your exam comes around, I want you to be confident. You don't have to be worrying about, you know, and cramming things. No. Step by step, every day you do a little bit, do your revision, do your practice a little bit each day, and it will accumulate, and so will your confidence. So students, I want to thank you for coming out to our first live graph class. For those who have not yet subscribed, I urge you to subscribe to the channel and to click that notification bell so that you will be notified in case you forgot. Someone wants me to remind them which topics we did earlier. You mean earlier today in this session? Earlier in this session? I'm not sure what you mean. What do you mean? What we covered in this graph class, we looked at coordinates. We looked at the coordinate plane and how to plot. And we looked at, if we're given the points already, how to determine the coordinates. And we looked at the quadrants, if that's what you meant. Or in the PEP class, or we did a performance task. In the live PEP class today, we covered the performance. We did a performance task. All of it, all of that paper we did today. But the video is on the channel, so if you missed it, you can go on and watch that as well. We went all the way through all 4 sections of the performance task. All right, so I'll see you tomorrow, and bring a friend, tell your neighbor, tell your classmates, your cousin, your mommy and daddy, bring them too and let them sit and watch. Let it be a family affair. All right, students, take care and thank you for coming. I'll see you tomorrow.